Hi, this is my research paper presentation, Finding and Using Biomarkers to Detect Cardiovascular Disease in Early Stages. Who am I? My name is Vipin Glen, and my mentor for this paper is Vincent. I chose to do this paper on cardiovascular disease because it's something that relates to my family's background, history, and genetics, and cardiology is also my interest. I'm currently zooming in from California. Why is this important? Cardiovascular disease, CVD, is a range of conditions that negatively affect the heart, like heart attacks, strokes, and hypertension, making it one of the leading causes of death globally. Current biomarkers for CVD are inconsistent and don't always provide accurate results for early detection. But first, what is a biomarker? Biomarkers are molecules found in the body to show signs of abnormal or normal processes of a condition. It can be used to see how the body responds to a treatment for the disease or condition. Biomarkers like troponin and C-reactive protein can show signs of heart problems, but can't be used to confidently conclude a patient CVD alone. But a promising alternative method for this is to use multiple biomarkers for a multiplex detection of CVD. Here, I discuss CVD biomarkers and the current state of CVD sensing, and with the future outlook towards non-invasive testing using different biofluids like sweat and urine, and to use a multiplex detection for biomarkers in CVD. The current state of CVD. There are significant advancements in identifying and measuring biomarkers for early CVD detection. A new tool called the CVD-21 panel was developed by researchers at Uppsala University in Sweden. The function of it is it measures 21 known biomarkers simultaneously from a small blood sample. This is efficient because it enables rapid and comprehensive assessment of a cardiovascular health. Emerging biomarkers are microRNAs, which show promise in early CVD detection, and TGF-beta. The impact of early diagnosis can be using these advanced tools to help detect CVD at an earlier stage. Here is the CVD-21 image. Here you can see the list of all 21 biomarkers that are in this diagram, and here in the middle are different cardiovascular diseases. CVD isn't just one disease, it's a broad term which encompasses many different problems like heart attacks, strokes. Here I'll be talking and discussing about 7 different biomarkers and their importance in detecting CVD. The first biomarker I'll be talking about is creatine. Creatine is an amino acid made from arginine, glycan, and methionine. The function of it is it stores and transports energies within cells, converts creatine phosphate to replenish ATP, and is essential for high power energy demands, such as using muscle, working out, running, and anything that involves physical activity. The normal amounts of creatine found in the blood are 0.6 to 1.2 mg/dl. In the muscle, it's 120 to 130 millimeters of dry muscle mass. 95% of creatine is stored in muscle, and the other 5% is in brain, heart, and other organs. Creatine is produced in liver, kidneys, pancreas, and can be ingested from meat, fish, and other high-level creatine amount foods. Excessive amounts of creatine can lead to water retention, muscle cramps, gastrointestinal issues, and severe kidney impact. Overuse of creatine can be using creatine supplements, which can cause kidney and liver damage. Lipoproteins. Lipoproteins are molecules formed by lipids, fats, and proteins, and their importance is in transporting cholesterol and lipids. There are different types of lipoproteins like HDL, LDL, and VLDL. HDL is good cholesterol, which removes cholesterol from the blood vessels, and normal amounts are 40 to 60 mg/dl. The bad cholesterol is LDL and VLDL, which can be found in deposits in the arteries. LDL should be lower than 100 milligrams/dl, and VLDL should be 2 to 30 milligrams per deciliter. High LDL or VLDL can cause atherosclerosis, which can lead to heart attacks, cardiovascular disease, and strokes. Atherosclerosis is fat buildup in the arteries. Lipoproteins can be measured through lipid panels and enzymatic assays like ELISA. Troponin. Troponin is a protein complex which regulates muscle contraction. It is primarily located in the heart and small amounts in skeletal muscle. High increased amounts of troponin can show heart damage and normally should be less than 0.01 ng/milliliter. Troponin can be found in blood tests, immunoassays, and rapid tests for diagnosing heart attacks. The next biomarker is fibrinogen. Fibrinogen is essential for blood clotting and converts fibrin to form clots. Normal levels of fibrinogen should be 200 to 400 milligrams per deciliter, and high levels can increase the risk of thrombosis, deep vein thrombosis, pulmonary embolism, and stroke. Fibrinogen is detected through blood tests, the Claus method, and immunoassays. Homocysteine. Homocysteine is a sulfur-containing amino acid involved in methylation and DNA repair. High amounts of homocysteine can suggest cardiovascular risk. These high levels can damage artery linings, leading to disease, stroke, and vascular disease. Homocysteine is detected through blood tests using high-performance liquid chromatography, HPLC, and immunoassays. TGF-beta. This is one I mentioned earlier and is a new emerging biomarker. TGF stands for transforming growth factor beta. It's a cytokine involved in cell growth, differentiating, and immune regulation. Normal levels should be 1 to 10 ng/milliliters in plasma, and overproduction can be linked to fibrosis, cancer, and autoimmune diseases. TGF-beta is also detected through immunoassays and bioassays to measure the biological activity. Last but not least, MPO. MPO is a biomarker and is an enzyme in neutrophils and produces hypochlorous acid to destroy pathogens. Normal levels is relatively low in healthy individuals, but it can increase during inflammation or infection. High levels of MPO can be linked to inflammatory diseases and CVD like atherosclerosis. MPO is measured through ELISAs, mainly in detecting inflammatory and cardiovascular risk. Conclusion and future directions. The importance of CVD early detection is a critical priority in the health field. New biomarkers like C-reactive protein and cardiac troponins are pivotal in CVD detection. My main focus in my paper is to find and use non-invasive testing methods. Currently, blood tests are the primary method for CVD risk and treatment assessment, but the cons outweigh the pros. Blood tests can be intrusive, have infection risk, bleeding, and clotting. Alternative methods to detect CVD through biomarkers can be like saliva testing and urine testing. Saliva testing can detect biomarkers like CRP, TGF-beta, and MPO for inflammation and cardiac stress. While urine testing, a test called urine albumin creatine ratio, identifies protein in the urine, which can signal heart and blood vessel disease risk. The benefits of multi-biomarkers. Using multiple biomarkers can offer a multidimensional view of cardiovascular disease health, and it can provide a more accurate and personalized CVD detection and treatment. The detailed assessment of CVD risk can be used through multiple different biomarkers, and early prevention and tailored management techniques for better patient outcomes are essential in early CVD risk detection. Thank you for listening to my presentation and hope you learned something from this.